All right, so we're going to be looking at questions 43 to 50. We're going to be solving using logarithms. Now, there's two types of cases we're going to see. Looking at 43 through 46, so let me just zoom into here. You're going to see the word log, the same log on both sides of the equal sign. Like I said, well, that's one of the cases. The other case you're going to see, looking at number 47, that's going to be 47 through 50, right? When I separate this, you're going to see the logs only on one side of the equal sign. So those are the two cases we're going to see. We know how to expand and how to condense our logarithms. As a matter of fact, I'm going to work an example that I want us to work on it just so we know what's going to happen later. Now here, question number 43. Because it's log of the same base, in this case, log of base 11 on both sides, in order for me to solve for the equation, I'm just going to say 4n plus 2 is equal to 3n plus 3. I'm just going to let these two equal each other. Solve for equation basically means find the value of the letter, right? We want to know what the value of letter of n makes us same and true. Okay, so let's see. Let me separate them through the equal sign. I want the n's together, so the 3n, let me move it to the left side. And then the plus 2, let me move it to the other side. Don't forget that we switched signs whenever we move from one side to the other. So here on the left, I see 4n minus 3n. So n equals. Now on the right side, I see a positive 3 minus 2. That's 1. So n is equal to 1. Okay. When it's the same base, we just let the two things in there equal each other. So here, I see log base of 5, and I see there's the equal sign in between. So the way I'm going to solve this, I'm just going to say negative 2x equals negative 4x minus 10. Let me separate them through the equal sign. I want the x's together. I'm going to move the smallest x. There's a negative 2 and there's a negative 4. Negative 4 is smaller. I'm going to move it as a plus 4x. Don't forget to switch the sign. So on the left side, I see negative 2 and a positive 4. So that gives me positive 2x equals negative 10. Let me divide both sides by 2. So I'm going to get x equals negative 5. Right, I solved. The value of x is equal to negative 5. We change to blue so we don't get confused. Looking at question number 45. Again, let me separate my sides through the equal sign. And I see the log base 11 on both sides. So I'm just going to write this as negative 2m plus 1 is equal to 9. My plus 1, let me move it over as a minus 1. So I have negative 2m is equal to 8, right? 9 minus 1. Let me divide by a negative 2. So I'm going to get m is equal to negative 4. Lastly, on number 46, and I say lastly because the first example, the first case, I see log base 20 on both sides of the equal sign. Let me rewrite this as negative 2a plus 8 equals negative 4a minus 10. All right, let me solve for a. So this negative 4a, let me move it over as a positive 4a. And this positive 8, let me move it over as a negative 8. Letters on one side, numbers on the other. Whenever you move something from one side to the other, you got to switch the sign. Now, negative 2a plus 4a, that's going to be 2a. Negative 10 and a negative 8, that gives me negative 18. Once I divide both sides by 2, I'm going to get a is equal to negative 9. Okay. Now let's take a look at the other case that I mentioned. What happens when log is only on one side? First of all, condense. So what I mean condense, let me rewrite this as log base forward of 6 over 3x is equal to 1. I condense my log. I did it as a fraction because it was a minus of 2 logs, right? The subtraction of 2 logs, as long as it's the same base, the subtraction of 2 logs is basically division in 1 log. Now, because I have log only on one side, let me rewrite this in exponential form. Remember exponential form, I gotta write this as an exponent. So I'm gonna go forward to the 1 equals 6 over 3x. 4 to the 1 equals 6 over 3x. Some of you might be, where do you get the 4 to the 1? You guys see where I get it from. Log base 4. You guys see where the 4 comes from. And the 1, because this is what the log is equal to. So 4 to the 1 equals 6 over 3x. Now 4 to the 1, isn't that just 4? So let me rewrite this as 4 is equal to 6 over 3x. Now, if you're like most people, you don't like fractions. So if you don't like fractions, get rid of it. I see a 3x at the bottom, so I'm going to multiply both sides by 3x. So that's going to give me 12x is equal to 6, right? Because those 3x's cancel out. I have 12x is equal to 6. Let me divide by 12. So x equals, now 6 over 12, at least let me simplify the fraction as 1/2. Don't forget, how do we type a fraction? 1/2. So it's okay to have a fraction. Just make sure you simplify. All right, let's take a look at question number 18. First, let me condense this. I'm going to say log base forward of x over x minus 5, it's equal to 1. I see log only on one side, so let me rewrite this in exponential form. 4 to the 1 is equal to x over x minus 5. And we're going to have that 4, because right, 4 to the 1 is 4, is equal to x over x minus 5. Remember, if you don't like fractions at the bottom, get rid of them. Multiply both sides by x minus 5. All right, so looking at on the left side of my equal sign, x minus 5 times 4. When we multiply, remember, I'm just going to distribute the 4. So that's going to give me 4x minus 20 equals x. Right on the right side, I only have an x. So 4x minus 20 is equal to x. Let me separate them through the equal sign. I'm going to move the x to the left side. So the plus x, let me move it as a minus. And this minus 20, let me move it as plus. So that gives me 3x is equal to 20. Divide both sides by 3. So I'm going to get x is equal to 20 over 3. It's okay to have fractions. Simplify 20 over 3. That's the best we can do. All right, so let's go here. Let me give myself some space here. I'll clear this up to give myself for 49 and 50. Okay, so let me rewrite question number 49. Let me rewrite that as log base 6. I have to simplify this first. So let me simplify this as x plus 7 times 3. And all this is equal to 1. All right, I don't do minus or I don't do division this time. I do times because of this plus sign. Okay, so I have 6 to the 1 is equal to x plus 7 times 3. The rest is just algebra, right? 6 to the 1 is not 6. Let me distribute the 3. So I got 3x plus 21. The plus 21, let me move it to the other side as a minus 21. So I get negative 15. It's equal to 3x. And once I divide by 3, I get that negative 5. It's equal to x. Okay, not too bad. Now, number 50. Promise I'm not going to give your homework this complicated. However, we have to start looking at these things. So let me condense first. Log base 3 of x times x plus 24 is equal to 4. Right? I combined it as multiplication of one log. So this gives me 3 to the 4th is equal to x times x plus 24. This is something that so far not bad. The interesting part here is 3 to the 4th, right? Multiply 3 times 3 times 3 times 3. That should give me 81. Now here, when I distribute the x, this gives me as x squared plus 24x. Okay, so like I said, I'm not going to get this complicated. And complicated means when I have an x squared. I'm not going to get this complicated just yet, but in a few weeks we will. That's what I want you guys to start looking at these. Now you recall from Algebra 1 that I'm just going to move the 81 to the right side. So let me write this as x squared plus 24x minus 81. And on this side is equal to 0 on the left side. All I did, I moved the 81 to the other side, right? I switched the sign. Now gotta solve for x. Now factored, right? Remember you guys did that in Algebra 1. So let me see. What I'm really looking for is two numbers that when I multiply my numbers is equal to negative 81. When I add my numbers is equal to positive 24. Hopefully that kind of rings a bell. So just let me think of my factors of 81. What I'm going to do, I'm going to think of the factors. I'm going to go 1 times 81. When I'm on my left side, let me just let me add my numbers like 1, 2, 3, 4, 5, 6. I can go my list as far as I need to. Now on the right side, 2 times what equals 81? I grab my calculator and I do the opposite division, the operation. 81 divided by 2. And it gives me a decimal, 40.5. All right, so this one's not good. I cannot get decimals. Now, how about 81 divided by 3? I grab my calculator. 81 divided by 3 is 27. Now, these factors I'm going to use, 3 and 27. 1 and 81 did not work because remember, I want my numbers to multiply equals 81. But when I add them, I want it to equal to positive 24. Because multiplication is negative 81, my signs are going to be different. So I'm going to use 3 and 27 because 3 times 27 equals 81. And when I subtract, because remember when the signs are different, you subtract. When I subtract, I get a 24. So let me think of positive 27 and a negative 3. When you multiply, it equals negative 81. When you add, equals 24. Remember in Algebra 1, you guys did this as x plus 27 and then x minus 3. If you let each of your parentheses equal to 0, x plus 27 equal to 0, x minus 3 equal to 0. If you let each of your parentheses equal to 0, solve for x. If x plus 27 equal to 0, can I just say x equals negative 27? If x minus 3 equal to 0, I can just say x is equal to 3. Now, a log can never be negative. So negative 27 it's not good, right? We can never do the log of something negative. So x equals negative 27, I'm not going to accept it. The only answer I will accept is x equals 3. Okay? So that's what we did today.